Hello everyone, welcome to this session. In this session, we'll talk about a very important topic which is read and write set. So whenever we work in Hyperledger Fabric, whatever information we store to ledger, whenever we read the information to from ledger, and whenever this endorsing peer, committing peer come into play, they all deal with read and write set. So basically, whatever the information get exchanged from client to endorsing peer, then endorsing to order service, from order service to committing peer. All these things are happening in a read and write set. So it's become very important to understand what is this read and write set and how it actually work and what benefit we'll get from this set basically. So let's get started and try to understand about this one. So as I mentioned that this is a read and write set. So generally people represent this as RW set as well. So if you heard this name as RW set or read and write set, both are same only. There is no difference between these because it's a short form of RW. Okay. So now, as I mentioned that this read and write set is very heavily used in Hyperledger Fabric. So how it look like and what help we'll get from this one. So if you see here the line which I have mentioned, this help the committing node, okay, the nodes who commit the transaction and who store the ledger also, they have to validate the transactions. So this read and write set help them to validate the transaction plus help them also to avoid double spending. So we'll try to understand about these two terms in the next session. For now, we'll talk about what is read and write set. So as you can see in this diagram, we have two set here. One is read set, one is write set. So always remember that read set contains just a key and version. So we have understand in the previous sessions that whenever we store the information to a ledger, we store in form of key and value pair. So your value can be a simple string value or it can be a JSON message as well. So, but whenever we talk about the read set will always have a key plus the version of that message. So we'll understand with one example in next slide. For now, just remember that read set always contain a key and the version. Now the write set contain a key plus value. So see here the difference, key is common in both the sets, but read set contain only version, not the value, but write set actually contain your value. So read set, as the name suggests, this is help you to read something from a ledger. Okay, so in case you want to verify what is the information there in a ledger, so this read set basically help you to validate your transaction because it is going to read something from ledger and help you to validate with your current transaction. And then write set, which is there, it is as the name suggests, this is going to help you to write something to a ledger. Okay, so just keeping this in mind at very basic level. Now let's try to understand that how this get created. Whenever we talk about a read write set, so whenever client or a application interact with your fabric network, we have understand that the transaction goes to endorsing peer, right? So clients always send the transaction to the endorsing peer, where endorsing peer, we all understand that these peer will have a chain code running. Okay, so these all the peer will have a chain code running. So whenever transactions comes to this endorsing peer, what this endorsing peer does, this endorsing peer will run the chain code with a given input which will receive from a client and it will have an output, right? So during that process on the endorsing peer, during the simulation, whenever chain code is run, this read and write set get created. So these read and write set will be specific to each endorsing peer. So in this example, if you see, we have three endorsing peers. So every peer will have its own read and write set. Okay, so this get created on the endorsing peer. And this is from where this whole thing gets started. So now let's try to understand about read set in the detail. So read set, I just mentioned that it contain key and version numbers as we have shown below. So this is a very simple diagram which shows that a read set contain a key suppose here I'm storing the car owner. So my car ID is 1234. So my key will become 1234, and this is currently on the version number 1. Okay, so this version depict that how many times this has changed. So suppose whenever you're storing this value to a ledger, you will store your car ID, who is the first owner. Suppose your car ID will remain same 1234. Your first owner is suppose Mark. So that will be marked as version 1. So once you change the ownership from Mark to someone else, that means it is a new owner has been assigned. So you have one more transaction, so the version will change from 1 to 2. So this is how it goes basically. So a complex read set can have multiple keys. You can see here we have key number 1 2 3 4 4 5 6 7 8 7 6 9, and there will be version defined for each and every key. So version can be 1, it can be 2, it can be 3. As the transaction grows, the version will also grow. The version will also change. And this is play a very very important role for your transaction validation, as we understand in the next few sessions. So for now, just remember that read set contain a key and the version number, which is going to help you to validate your transaction. Now in the reverse, write set contain the key and the value. We have understand, right? In the previous slides also, the example is that I was saying that suppose we are storing the value of a car owner. So now you have received a transaction from the client saying that my new owner is Joe. Okay, the transfer has been done from Mark to Joe. So now a write set is coming, has the key remains same, the car ID remains same, the value is Joe, right? This is your read set. And again, you can have multiple write sets also, right? It's like you can see every set will have its own key and value. So this is how your write set will look like. So this read and write will come in one set. It's not like that you will get a read separately, write separately. So this read and write set both comes in one transaction basically. This happen in only one transactions. All right. So then how it works basically, as we have understand till now about read and write set, that read is going to store your key and value pair version, and write is going to store your key and value. Now, let's talk about how this help you, how it actually work, and what we can do with this one. If you remember, we talk about that read and write set will help you to perform two things. First, the validation of your transaction, plus second thing, it will help you to avoid double spending. So when we talk about the validation, so till now we have understand that whenever transaction is initiated from client, it goes to endorsing peer, and this is where this read and write set get created. Okay, and finally when this transaction goes to ordering service, then this ordering service will send the transaction to the your committing peer as well, which finally commit your transaction, right? So what happened whenever this transaction, this read and write set reaches to your committing peer? So what they have to do? So spelling is wrong here for committing. So I will make it correct. But for now, just remember that what this peer will do actually. Okay, whenever we talk up, whenever the transaction this read and write set reaches to this committing peer, so this will have a read and a write set. So read, as we understand that it will have a key and version. Write will have the key and the value, right? So this is something we have understand till now. Okay. So now this committing peer will also holding a ledger. So when we talk about a ledger, ledger is going to store your key and value, and it will also have a version. So in the current ledger I have stored like my car ID is 1234 and the value is Louis, who is the current owner of this car, and the version of this asset is currently in the first version. Now whenever this read and write set comes to the committing peer, what committing peer does, first of all, committing peer will goes to this ledger. It will take this read set, first of all the key and the version. It will try to match the key and the version in the ledger. Okay, if it matches the key, for a given key the version should match. Okay, if the version is matching, like here we have one, here we have one, so it is matching, that means your transaction is valid. Then it will take this write set and it will update its ledger. In case the version is not matching, then it will reject this transaction, because for transaction to validate, the version has to be matching in the result set, in the read and write set, and the your ledger. Second thing what it does, then you can see here, once the validation is completed, as I mentioned earlier, your ledger will get updated with the keys remain same. The value now become Joe, right? Now the version is also get changed to 2. Okay, once the write set is successful, you will write the information to your ledger. You will increment the version by 2, by 1 basically. So it was 1 before, now you have 2. If you got one more request, then the version will also get changed from 2 to 3. So this is how the version get updated. So this is how the validation works basically. Now let's understand how it helps you to avoid double spending. So first of all, let's understand what double spending basically. So double spending, in if I explain in a very simple term, you have $10 in your account and you're trying to become smart. You are trying to send the same $10 twice to different people. Okay, so then that is not a double spending. You have only $10, but you are trying to spend $20. You are trying to initiate two transactions at a given time with the same value. So how we can avoid that in a Hyperledger Fabric? Let's try to understand. So whenever you try to initiate two transactions, let's take an example here. So the current owner was Louis, okay, and the value which we were having in the ledger was key is 1234. The value was Louis, and the version was 1. Now user has initiated two transactions. In the first transaction, he has mentioned that I want to change the ownership to Joe. In second transaction, he mentioned for the same car, I want to transfer ownership to Jack. Now, how to handle this one? So one transaction should be successful, one should be rejected. So how it works actually? Whenever this transaction will come, first of all, this first read and write will come to committing peer. He will validate the version 1. If you remember in the previous slide, we had talked about that if version 1 is matching. So earlier, your ledger was having key as 123, value was Louis, and version was 1. So when this result set read and write set comes first, it will validate the version is matching 1, and then it will update the owner to Joe. Now your ledger will look like this way: 1234 value is Joe, and version is 2. Now it will take the second read and write side. Here the version we have got is 1, but the value is Jack. Now what this peer will do, we have understand, this will compare the version first of all. So here version is 1, but here the version is 2. So there is a mismatch, right? So what committing peer will know that something is wrong. So version is not matching. So ideally the version should be 1 here in the ledger, like the way we have in the read set. But now the version is got changed by other write set. So this transaction will get rejected. So your committing peer will reject your second transaction, which is your invalid transaction. So this is how the double spending is avoided or handled in the Hyperledger Fabric, because the version play very important role here. This version is the main thing where this committing peer will validate whether the version is matching or not. As long as your version is matching, you will write the information. If the version is not matching, you will simply say this is your invalid transaction. So this is how the read and write side play very important role in a fabric.